Great. Yeah, I seem to be live. Awesome. Let me just switch to my PowerPoint here and let me begin. Um, Great. Okay. I have some, let's start with this. I have some YouTube chat for you available. So if there's any issues, let me know. Great. So, hi everyone. It's great to be here. My name is Sander ten Brinke. And in these next 40 minutes, I'm going to teach you everything that you need to know about configuration and secret management in .NET. And you might be wondering, why would I want to talk about this? Well, it's because it is not maybe that tough to use configuration. That is true. It is not that tough to use configuration in .NET, but it is pretty tough to set it up in a correct and secure way. I've been at multiple projects, I've been at multiple companies, and it's been many years since .NET Framework, but I still see a lot of old-fashioned or unique ways to set up and use configuration in .NET. So I want to show you how to use the modern versions and what you should do and what you shouldn't do, how to keep secrets safe, etc. So before we begin, let's quickly have a look at what configuration is. So to me, configuration is things like logging settings, feature flags, URLs for external APIs, etc. Things like secrets are API keys, connection strings, things like this to say kind of make the difference, and they always kind of belong together. Before we continue, a quick word. A big thanks to the sponsors for the Rome.net conference for making this conference possible. And next up, let's talk about me for a little bit. So my name is Sander ten Brinke. I am from the Netherlands. I live in a city called Apeldoorn. And I am a lead software engineer at Arcady, which is a consultancy company. Next to that, I'm also a Microsoft MVP. And I really love working with things like .NET and Azure, or backends in general, app development, cloud, DevOps, frontend. As you can see, I really like doing everything. I also really love staying up to date with the newest technologies, and I love blogging about it. I love talking about it like I'm doing now. Later on, I think we might have some more of these links to my socials if you want to follow me or read the blog posts at WhatsApp or whatever. Feel free to ask questions in the chat. I have it right here on my phone, so any questions I can read out immediately, or feel free to save them until the end. Okay, so the agenda. So I kind of split it up into 4 sections. First, we're going to talk about the basics of configuration in .NET. Then we're going to talk about the options pattern, which is basically the way you should really be using options configuration. Next, we're going to talk about keeping secrets safe during development. And when that is done, we're going to talk about storing secrets in the cloud. Before we begin with this, I just want to do a quick mention because, of course, this is a virtual conference. So if you have any questions or if you have any fun things to share about how you use configuration or how you manage your secrets, there's just questions about it, whatever, feel free to share them in the chat so we can have a little discussion about it if we have time left over. Okay, so let's talk about the basics of configuration. So in .NET, we basically have the interface iConfiguration, which is the endpoint for all of your configuration needs. And there's loads of providers behind it. So when you access configuration using iConfiguration, it can either pull it from, for example, appsettings.json, appsettings.development.json, environment variables, command line arguments, and other sources. And these other sources are interesting. They're things like cloud configuration providers or your own provider that you wrote for some, for a text file, stuff like this. You can make your own configuration providers as well. And this iConfiguration is an abstraction on top of all of this, because when you retrieve configuration values from this system, you cannot specify what provider you're going to get it from. And that's actually quite interesting. And that also makes it very powerful and very flexible, because the way you set up your system is the way it's going to work. We're going to talk more about that later. So this presentation is going to cover a lot of C# code, excuse me, and a lot of C# code samples. So we begin with a bit of basic configuration usage in .NET. So we have an interface of iConfiguration. We have an instance of this, and then we could have a method called getAPIKey. Now, what you can do is you can call getValue. So you can say getValue of type string and give me the API key, or you could say give me the API key as an indexer. No, let me just fix that. There you go. And what the first one does is it will give you a strongly typed type back. So it would give you a string or an int or a boolean, whatever you prefer. The second one would always return a string. So I prefer using get value for like mapping something to an int if it's an int, instead of having to do that myself afterwards. So just very nice. As you can see here, though, you're not specifying a provider. Great. So this also, because you're not having any providers, you also can be very flexible because your application shouldn't care. This allows us to decouple our configuration system and our application code. Wonderful. So the really powerful feature of configuration in .NET is that there is configuration structure. One of the well-known ways to work with this is the app settings.json file. So this is a pretty normal looking file with logging and with some allowed host properties. There's a connection strings object with a database property in it. There's some feature flags, etc. And well, you can actually interact with these sections. You can treat it as separate little bits of configuration instead of having to treat it as a key value. So let's have a look. So what you can do is you can go ahead and say, well, I have another instance of iConfiguration, and we have a method called getFeatureSection, which would return to you an iConfiguration section instance. And you can interact with these sections in two ways. You can go ahead and say, well, getSection, or you can say getRequiredSection, and you pass in the string type of the string of the configuration. Now, of course, you might be thinking, well, it has to be JSON because there's features here and there's features there. But of course, this is just a provider. You could also have a provider in any other languages and any other file type as well. GetSection would return an empty object if the section doesn't exist. GetRequiredSection will throw an error, which I prefer because configuration doesn't really change all that often. And with this instance of iConfiguration we can go ahead and we'll call the same things on it as with iConfiguration. So we can get values from it. We can dive into deeper sections, stuff like this. You can also go ahead and say, well, I don't really want to work with sections and stuff like that. I just want to get a deeper value immediately. In this case, you can use like features : enable new UI, and the colon will allow you to go one level deeper. So this is kind of the structured way of working with configuration. I don't recommend that you do this. We're going to talk more about this later. You might hear me repeat that a few times. You should really be using the options pattern in business code. But I think it's important that you know that these kind of structured things exist. So how does this all work? Well, to get to an instance of iConfiguration, you need to create a configuration setup. So you want to create an iConfiguration builder, then we're going to add some providers to it. We're going to call build on the builder, and we're going to finally end up with an iConfiguration root instance. This is kind of the same as iConfiguration, except it also has a list of all the providers. You shouldn't really be using this. If you're going to be using iConfiguration, you should always use iConfiguration. And in code, this is pretty simple. We can create a new instance of configuration builder. We can call some methods on it, like add environment variables or add JSON file. And we can finally call builder.build, which would end up with our configuration system. And this is pretty interesting because how does this then work? How does it know where to retrieve values from if we have two files that have, for example, a value for the same key? This is because it is all based on the order of the providers that you added. So you could have, for example, a shared settings.json, you could have an app settings.json, and finally you add an environment variables. If you look at it top down, you can actually see that there's overlap between environment variables, app settings.json, and shared settings.json. So a key, for example, API key would exist in environment variables, then it would be retrieved from there. If something else, like a feature flag, only existed in app settings.json, it would ignore environment variables and it would grab it from app settings. That's kind of how this stuff works. So the order in which you add providers is very important. And you might be wondering, at least I had this a lot at conferences where I ask people, so who here has used configuration? And almost everyone raises their hands. Whereas I asked the audience, hey, who here has created and messed around with configuration builders before? And there's a lot fewer hands. That's because with .NET, you actually get a lot of default configuration out of the box. So if you're, for example, creating with the new modern .NET, you're creating web applications with web application.create builder, or you're creating a worker service with host.create default builder, for example, then you actually get a default configuration system out of the box, which is really, really good and suits a lot of needs. So let's have a look. There we go. So we end up, or we begin rather, with the app settings.json file. And this file is what we saw before, right? It's it's a JSON file that you, for example, get with ASP.NET Core projects or with worker services. And next up, there's the app settings.environment.json. And this environment is, well, configurable. You have an environment variable in your system called .NET environment or ASP.NET Core environment, and this has a value. For example, when you take a look in a .NET project in a properties folder, you will see a launch settings.json file. And in there, you will see an environment variable, .NET environment, with the value development. And so that is why you have an app settings.json and an app settings.development.json that magically works. The power of this is that you could create an app settings.test.json and an app settings.production.json. And then on your different environments, you can change this environment variable on the system or on the process to that name, so to test or to production, which would then load in different configuration files. This is very powerful because you could, for example, say in the app settings.json, I have a feature flag set to false because it isn't done yet, like enable new UI. And in app settings.development.json, it's true because we're still working on it. It's already in a testing phase, so we're going to enable it in app settings.test.json as well. But in production, for example, we also set it to false or on a staging environment. So this way you can create environment-specific configuration files. Right. Next up, user secrets. Now, this is another default provider that you only get during development, and you should always be using this to store your secrets, or what I prefer to do also, developer-specific configuration. And we're going to dedicate an entire section to this later. So for now, we're going to continue to environment variables. Now, environment variables are very popular in a Docker and Kubernetes world and stuff like that, whereas you can also just set up configuration values and secret values. And finally, there's command line arguments, things like .NET run, and then you can pass in a key. And in this case, if we were to pass in -- key with the value, important value, you would actually go ahead and see that when you ask the code, hey, give me the value for key, it would actually return important value because this is the provider with the highest priority. And any providers you add yourself will have even higher priority. Let me just get the comment section back up. There we go, just in case anyone asks questions. Right. This is basically how the default system works in .NET. And it works, but there's actually a couple of downsides, and we can fix those with the options pattern. So let's take a look at these. So a downside of using iConfiguration is if you were to use it in a way like this. We talked about structure, right? So we could have an object, we could have something like external API settings in our providers, and it would have an API URL, an API key, maybe also a timeout in milliseconds. Now you could map this to a class. It would be great. You could create a class called external API settings, and then you could create like an API URL, API key, timeout in milliseconds. Then you could map these together. So you could treat this as code. You could add methods to it, like for validation or for further cool string manipulation or configuration manipulation. You could treat configuration as code, which is very powerful. So how do we do this in our classic example? Well, you would go ahead and say we have a class, external API client, and this has an instance of iConfiguration. And in this call external API method, you can see that we can call get section, and this would then call get on it. And this would map the data to that instance. So it would look for a section called external API settings, and it would look for all the properties in the class, and it would look for that in the JSON or in every provider you have, and then it would map it to an instance. And you could also call bind if you have an existing instance. Now, what this does is now you have an instance of the configuration class, and you can use this to do API calls. But there's actually 3 pretty big downsides to this sort of approach, because you can now access all of your irrelevant configuration data, which is not really desirable. We want to write code that does as little as it needs. So it's, we have like clear boundaries of what our code does. But now this class could access any connection string it wants, which is not really great. It could access logging settings. It could access other API keys it doesn't need access to. This means that also this class has now knowledge of configuration structure. So you could go ahead and, as you can see here, you can pass in the string from the configuration section. And now if your configuration structure changes, for example, we're changing external API settings to external API options, Now at runtime, this would break because suddenly your external API client broke. And that's just weird. Why would we connect our configuration system to an external API client class? This is bound together way too tightly. And finally, you also have magic strings in your code base, which is also just not really desirable. So we don't want to be doing this. We don't want to have all of these downsides. So how do we fix them? Well, we can use the options pattern. Now, the options pattern is a way better way to work with configuration. It provides loads of cool features like encapsulation and dependency injection. Validation is my favorite one. Things like named options and supporting configuration reloads at runtime, post configuration. There's so much stuff here. We're not going to cover all of it, but let's take a look. Now, you can use this with dependency injection. It works really well with this. You don't have to. Next up, what you need to know is we're currently here in this code, we're connecting our configuration system to the options pattern, but it is not tightly connected to each other. You could also set up options using the result of an API call or some other bit of code. It doesn't really matter. Here we're saying in our application startup, we're doing .configure. We're passing in the type, and then we're passing in our configuration. And now what this will do is when this is accessed in our code, it will then look for external API settings in our configuration system, and it will look for all those properties and map it to an instance of it. That would make our code look a whole lot cleaner. So now we inject an instance of iOptions with generic type external API settings, and we can store this by calling .value on it. And when you call .value, that is the moment when it will actually go to your configuration system and figure all of this stuff out. So it's lazy. It only does it when it's initially called. Second of all, it's a singleton, this one, the iOptions instance. So when you call .value on it again at a later point, maybe in a next request or later on in the lifetime of this class, or even another class, it would just return a cached value. So it's very efficient compared to like retrieving the configuration multiple times. And now you have an instance of your external API settings in this class. So now it's no longer tightly bound to your configuration system. And now it doesn't have any knowledge of the configuration system. It cannot access any more configuration, like it can only access what it got. And there's no more magic strings. So we really want to be using the options pattern whenever you're using configuration. So you can put your configuration into a class, and you can decouple your code from your configuration. The coolest thing, like I already said, for me, is options and configuration validation. We all know that validation is very important when we're writing applications, right? So we want to make sure that when a user creates a request to an API, we want to validate that input. Because the user could be sending something like a SQL injection or a virus to the server or some other malicious bit of code, and we want to validate against that. But a lot of people don't validate their configuration. And that's even more important, maybe. Because what if someone on the test environment accidentally connected the database to the production environment? That would make it very, very scary if someone were to test like data deletion, because now suddenly you're deleting stuff from your production database. Now, we're not going to cover this exactly, but it is important, as an example, to validate your configuration system. And you can do this. One of the well-known ways is to use things like attributes. So you could have a required attribute on the API URL or an API key, or you can have a range attribute, which means that the timeout in milliseconds needs to be between 1 and 100,000. Now, how can you use this? It's very simple. In your application, you could go ahead and say services.addOptions with the external API settings. You can call bind configuration, and this would just kind of handle all of the passing in the configuration instance for you. And now you can call validate data annotations and validate on start. Calling validate on start is really, really important to me because, like I said, accessing .value or like reading the configuration only happens when you call .value on it, which could be half an hour after application startup. And you want to validate these things when the application starts. So it crashes immediately and you can fix your issues instead of half an hour or like middle of the night, it just randomly finds out that your configuration is wrong. So what this will do is this will grab all of your configuration and it will match it against your attributes. Maybe you're not a big fan of attributes, so there's also ways to like write your own validation logic. There's packages available, so you can use like Fluent validation, stuff like this. So I really recommend that you use this. Validate your configuration system. So now that we know that we need to start using the options pattern to use configuration in .NET, how do we keep our secrets safe? Well, it starts at the development of your app because, well, never ever store secrets in the repository itself. Do not put them in your app settings.json. Do not put them in your app settings.development.json. Even if it's just for a test environment, please do not do so. Once you've committed something and pushed it to the server and your source code is leaked in the future, someone could simply go back to a previous commit and see the state of your code then and find your secrets. You want to make sure that these are never in your repository. So the recommended way to do this in .NET is to use user secrets, which is another configuration provider. So what you can do is you can call .NET user secrets init. You can then, for example, call .NET user secrets set, and you can set a key and a value, stuff like this. What this will do is this will create a file, a secrets.json file on Windows in your app data directory, and it will store it in a .microsoft folder somewhere on Mac and Linux in your home directory. So this is outside of your Git repository, which makes it more secure. And you can also easily use this in Visual Studio, and you can also easily use this in Writer. I want to demo this if we have time left over. And this will simply create another JSON file and store all of this stuff into it. Right. One thing about this is that, of course, now if you are storing currently your secrets in your repository, it's very easy for a developer to get started because they can just clone the repo and start because everything is already configured. When we're using user secrets, it is no longer configured. So we need to set up the secrets ourselves when we clone a repo. I recommend that you make it very easy for your team or for yourself to do this. So create a little script that writes some code and connects to the secret store and calls these commands to set up the secret store, the user secrets. Or maybe write a little README with some information about, hey, you need to set up these user secrets in this way, and you can find them in Bitwarden or in LastPass or wherever you store your secrets. And so it makes it easy for a developer to work with this. Great. We're running a little low on time, so we're going to have to go through this a bit quicker. So a good setup for local development that I recommend is that we do the following. So in our app settings.json, I have connection strings to a database, but I don't store it there, right? I say you can find this in the Azure Key Vault, which is a service from the Azure cloud to store secrets. The admin password, it can also be found in the Key Vault, and the welcome text, well, that's just stored in app settings.json, so we store it there. In app settings.development.json, we can simply go ahead and say, well, the database connection string should be stored in user secrets and the admin password as well. This kind of prevents behavior from other developers that are used to storing it in app settings.development.json. Now you'll kind of stop them on time and say, hey, you should store them there. This also makes it very easy because I might have a different connection string than you. If to connect to my database, I might be using Docker, you might be using a native server, SQL Server, for example. So storing like local configuration in your user secrets also prevents a lot of like commit fighting. And finally, in your user secrets is where you actually store, the actual secrets. Right. So now that we know how to work with all of this, how do we store secrets in the cloud? Because the user secrets provider only works for the local development environment. So the most popular way to do things like this are using like environment variables or storing secrets like with a place or creating placeholders in your app settings.json and then replacing them during the release. While this all works, the environment variables is fine. I'm not really happy with this app settings.json approach that I often see because it's just kind of abusing the configuration system. You should just add a new configuration provider for something like this. Or you could maybe using the Azure Key Vault. So the Azure Key Vault is an Azure service that is simply a secure way to store secrets or keys or certificates. Amazon has their own secret manager. Google has their own. You can even self-host this kind of stuff with the HashiCorp Vault. And the cool thing is that this can be used as a configuration provider in .NET. So in your application startup, you can go ahead and say configuration, builder, add Azure Key Vault, and then you can just simply add the URL to the Key Vault or to where the secrets are located. And you add your authentication, which we're going to talk about next. And now in your code, you can go ahead and simply say configuration get value API key, and it would actually just grab it from the Azure Key Vault. This is really powerful because now you don't have to set up the release pipeline anymore and like replace tokens and stuff like this. You can simply at runtime connect to the secret store. The Azure Key Vault is actually very, very cheap. So for like 10,000 calls to retrieve secrets, it's like 30 cents. So like euro cents. So it doesn't really, cost anything. And another cool thing you can do to improve your developer experience is to also use this when you're running locally. So instead of having to set up user secrets, you could also connect to the Key Vault locally. So a developer could just clone your repo and run it, and it would automatically connect to the key store in a secure way, which is a really, really nice way to work with code. So you don't have to like read the long README and run lots of scripts. No, it's just done automatically for you. So you might be wondering, how does this work? How do I connect to an Azure Key Vault securely? I would probably need to pass in like a username and a password. But if I have to, where do I store this? If I store this in an app settings.json, we're kind of back at the beginning where we're storing secrets in our repository. Because if a hacker could obtain our username and our password, it would suddenly have access to the Key Vault, and then he has access to the secrets. Now, if you remember from this previous slide, we have this default Azure credential. And what this basically does is this uses multiple ways to connect to Azure. So for example, if you're using Visual Studio or Visual Studio Code or Writer or the Azure CLI or Azure PowerShell, it will simply look for Azure or Microsoft credentials and then connect to Azure with those. So it's really easy to set up. And now you can simply connect to different Azure services. So what it actually does under the hood is the default Azure credentials, and there's a credential available for each of these little steps. There's things like the application service principal, which we're not going to talk about much today. Then it will try the managed identity, which we'll cover in the next slide. Then it will, during development, it will try like the Visual Studio Code or Visual Studio credential, the Azure CLI credential, the Azure PowerShell credential. So it will try multiple ways to talk to your Azure environment. This might all sound kind of magical and kind of, tough to understand. That's why we're also gonna do this in the demo in a bit. And managed identities. I said I would talk about these. So what are Azure managed identities? So Azure managed identities is a way to safely communicate with Azure services without having to use any secrets. Because the actual secret part of the communication, the secure communication, is managed by Azure. And this is supported by lots of Azure services. So what you can imagine is that we have like a virtual machine or an app service or an Azure container app or something hosted in Azure. And we have another service like a database, and we've told it like this virtual machine can connect to the database. And then when you're trying to connect to it, it will go to Azure Active Directory, or now known as Microsoft Entra, and it will obtain a token for this communication. And then the virtual machine is going to use that token to talk to your database. Sounds kind of weird. I recommend that you read a bit more about this if you're interested, because it's kind of a tough thing to maybe understand. But all of the secure parts are managed by Azure. And it works really, really, really well. Now we have about 12 minutes left, which is great because now I can spend some time on the demo. And then we're going to talk a little bit more about some extra tips and tricks, and we have some time for questions left over. So let me get this all ready. Right, let me just quickly check the stream to see if you can see my code. Yes, you can. Wonderful. So let me put the code here. Great. So this code, which is also accessible on my GitHub page, I'll have a link to it later, is a little application, a little web API that connects to a database and will return you a list of pizzas. And it also has an endpoint to get the connection string that we're using to connect to this database. So it's a really simple web application. And the cool thing is that here in our application startup, we are going ahead and, why is this not working? There we go. We are saying here at the application startup when we're not running on development, connect to the Azure Key Vault. So this is now an extra configuration provider added to our system. And now what it will do is it will, when we're getting a list of pizzas, it will get the pizza database and it will get the pizzas, it will stream the pizzas back to the client, or it has an endpoint which returns the connection string from our configuration system. You should be using the options pattern here, but since it's such a simple demo, it is not really worth all the extra effort. What I want to show you is our app settings.json file, which is basically, well, what I said before. So the connection string to the database is from the key vault, and the key vault name is this. And now if we look into the app settings.development.json, you can see that the database connection string is also kind of empty. It's just from user secrets. So how do you access these in Visual Studio? You can right-click on a project, and you can see here, manage user secrets. So let's click on this. And now you can see here my connection string to my local database, which is now stored in my local computer, right? In my C drive somewhere in the app data. So this is a completely secure way to store secrets. And what this will do now is we're going to demo this. So I have a version of this code running right here. And I'm going to show that this works. So I'm going to connect to my database, and it's going to return me a list of 3 pizzas. So a salami pizza, a Hawaii pizza, a margarita pizza. And the connection string that we're using to connect to this is the one that I just showed you, right? The server, local host, stuff like this. Now, the interesting thing now is that I've also deployed this to the cloud. I've deployed this to the Azure cloud. And I'm going to show you that this is done in a secure way. The secrets are managed securely. I'm going to show you again, we're connecting to an Azure database from an Azure app service, and we're getting the same list of pizzas back. It's a different database. But now the connection string, I'm going to show you. I'm going to show you the connection string to my database. And normally, you should never do this, because a connection string will contain secrets like the username and the password. And now if I had done something insecure like this, you would have been able to connect to my database and, delete it or stole my data. But let's have a look. So we can see there's a connection string to a database. You can see there is some more stuff. But the interesting thing is there's no username or password anywhere. It just says authentication is Azure Active Directory default. So what this will do is it will try multiple ways to talk to my Azure database from my Azure App Service without me having to specify any secrets. You could pause the stream or look back at it and type in this connection string in your own code and connect to it, but it wouldn't work because I have not authorized you in Azure to access my services. So the best way to manage secrets in Azure is to not use any secrets at all and just let Azure manage them. So how does this work? Well, in Azure, I have, you need to enable your Microsoft Entra ID. You need to enable a Microsoft Entra admin. And now you can create managed identities. So in my Azure App Service, I have set up the identity. So here I have a system assigned managed identity is turned on. And then in the database, I've given it access in the role assignments. So you can see here that my app service has access to the database. You also need to execute a little query on your database to make this work, which is also in the repository on Git. And now my application can talk to the database. Of course, it still needs the string, right? It still needs the connection string. So how does that work? It needs to connect to the key vault. And that also needs to be done in a secure way. The cool thing is that also worked with that default Azure credential again. So here I have my key vault, and here I have the connection string to the database. And I've simply set up that I have set up in the access control and somewhere else here that I think here, access policies, there we go. I've set up that my application can access the secrets, and I've also given it access control using the managed identity. So this is an easy way to store secrets in your key vault in a secure way and connect with it at runtime. But if you want to talk to other Azure services, you can simply go ahead and use managed identities to not have to talk or think about secrets at all. So that was a really quick demo. We have not a lot of time left. I want to leave some time for questions. So let's go back to the slides. There we go. Great. So we have a little bit of time left, so quickly talk about Azure App Configuration. So Azure App Configuration is another Azure service, which is basically configuration as a service. So I would recommend that you look into this as your preferred configuration store. So you don't have to think about where to store it in multiple providers. You can use Azure App Configuration and use all of its really, really cool features. And yeah, go ahead and take a look at that in your own time. Some final tips. I recommend that you read the configuration docs, like on the Microsoft Learn. I want to recommend that you use a secret scanning service like Git leak, so that if you accidentally commit anything bad, it would stop it from being pushed. This is also, I think, nowadays a part of GitHub Advanced Security. And there's loads of other tips here that you can read and probably already have read. One final thing is for every session that I give, every session that I talk about, I also write a blog post. So this one has a very extensive blog post available to read, so you can read everything back that I talked about today, and you can kind of learn more. With all of that, I see that I have about 4 minutes left. So with this, I come to the end of my session. And yeah, thank you so much for attending my session today. Thank you for attending the .NET Rome conference today. I believe there's one session left after this. Please read my blog post, and please leave some feedback by scanning this QR code. And I'll answer any questions now. I'm just going to load up the chat here.